Assalamualaikum warahmatullahi wabarakatuh, and good day to my panels, Prof. Nur AINI binti WAHAB, Dr. BIBI INTAN SURAYA binti MURAT, and fellow viewers. I am AFIQ SYAZWAN bin Nur AZMAN SHAH, and my supervisor for this project is TS Dr. Nur FAZLI bin ADULL MANAN. Today I'll be presenting my FYP1 proposal, Analysis of cranial mixture under impact and tension behavior. A little bit of summary of this project is preparing a sample that illustrate the cranium and conduct testings. What is the cranium? The cranium is the section of the skull that contains the bones that enclose the brain. Next, when two or more bodies contact, a strong force delivered in a short time period is called impact. For tension, it is defined as axially transmitted pulling force. In other words, it is the opposite of compression. The sample is made up of 4 elements by mixing the silicon, resin, zinc hydroxyapatite, and nickel titanium, also known as nitinol. Problem statement. A human skull 3D model was recently constructed and its biomechanical characteristics were investigated. Despite this, the fundamental mechanisms are still experimental. Furthermore, the skull's complicated shape makes it difficult to describe how it deforms. In recent studies, few materials are used to construct the cranium, such that polymethyl methacrylate is one of the most often used materials for cranial reconstruction with satisfactory long-term effects. However, to obtain the desired implant shape, the molding is done with specialized industrial 3D printers. So these procedures are very costly, and the sterilization issues are the most common problem for the usage of polymethyl methacrylate. Titanium is the allogenic material with great mechanical strength. The implants provide maximum stability and is resistant to subsequent damage. In other hand, intraoperative implant adjustment by using integrated titanium screws may be extremely difficult. Last but not least, the use of thermally polymerized acrylic allows the production of cheap and durable biocompatible implants without the risk of monomer residue. Unlike other materials such as titanium, acrylic is easy to cast, but the drawback is the preparation of the stereolithography master and biomodel took up to a month. The objectives of this project is to develop new mixture of cranium and to identify the tensile strength and impact properties for the cranium mixture. The scope of the project. The mixture consists of 4 elements, which are silicon, resin, zinc hydroxyapatite, and nitinol. The scope for impact testing is by using Chappie impact test machine obeying the standard ASTM E23, while tensile test uses Instron tensile testing machine following the standard ISO 42721 BIBI. 10 samples of each test resulting to 20 samples in total. Next, methodology. Methodology is a collection of methods, processes, techniques, and rules of a project. The flow of methodology of this project is from sample preparation, impact and tensile testing, then analyze and tabulation of data. Sample preparation. The mixture of each element is described. Silicon and resin are used 30 to 40%, while zinc, HA and nitinol are 10 to 20%, forming a cranium mixture sample. Samples shall vary of its mixture ratio, as shown in table on the right side, in order to achieve the most similar result as the real skull. Impact testing. According to standard ASTM E23, the test sample shall follow as the sample shown in figure. The testing tool is pendulum impact tester, and the frontal part of skull can withstand up to 6.2 kN of impact before it fractures. For tensile testing, the test sample is shown as the figure on the left side. Following the standard ISO 527-1 BIBI, the tensile strength of the cranium is about 67.73 megapascal with the tolerance of 17.80 megapascal. The test is carried out by using Instron test machine. Next, the data that collected during testings will go through analysis to compare with the real skull. Then the tabulation of data takes place after the analysis of data to construct possible tables and graphs such as stress strain graph. The literature review that I've made relating to this project. Skull bones. Skull bones is the brain is rounded and protected by calvarium, which is the upper part of the cranium, and can be divided into regions. Peak force. The inertia characteristics of the head and the surface impact determine the impact force. The table shows the impact force for fracture at different regions by drop test. The peak force is averaging at 4 to 5 kN. In vitro experiment. In vitro experiment is an experiment done in the lab with or within a living organism. The common examples of this type of experiments are animal model research and human clinical trials. A study describes that 15 mm of increment in the frontal part of skull after 750 Newton of force is applied. Expected result. A pilot test sample is prepared as shown. The expected or preliminary results will be similarly to the previous studies. Peak force or impact strength at 4.2 kN, tensile strength at 67.73 plus minus 17.80 megapascal, and the elastic modulus at 8.51 GPa. Some mechanical properties of artificial implanted skulls are concluded in the graph. Last but not least, here are the references throughout this proposal. And that's all from me for the presentation of proposal of analysis of cranium mixture under impact and tension behavior. Thank you to my panels for your time evaluating my presentation. Do contact me if there are any questions regarding my proposal. Thank you and have a nice day.